First, I want to show you the wiring diagram to kind of get an idea of how things all connect together. So let's start over here at our AC input. Right, so that's coming into here. We've got a 5 volt and a 12 volt AC to DC buck converter. The 5 volt is used obviously for our 5 volt logic, such as our Arduino Nano and the Adafruit soundboard. The 12 volt is used to power the lights. So if you happen to be using 5 volt LEDs or whatever your power source is, this can change depending upon what you decide to use here. You can use Christmas lights, anything you want to, just be aware of what the voltage is. So as we've got our AC coming in, the 5 volt powers the Arduino Nano, Adafruit soundboard, and also our relay. We've got the Arduino Nano that connects the VCC and ground of the relay, and then it also connects to the activating pins. This relay happened to be a ground activating pin, so then I attach to my digital pins, and in my code I respectively activate these by telling the digital pin to go to low. Same with the Adafruit soundboard. The sound plays when the pins are activated to ground. So I have these digital pins here that then connect to the Adafruit soundboard and respectively will activate ground to play the song. From there we've also got the power that powers the Adafruit soundboard. From the soundboard we have a right, left, and ground that goes out to our speaker, and that is just an auxiliary cable, a headphone cable, what you normally see, and I explain that a little bit more in detail. Alright, so that's pretty much all we need for the 5 volt signal. For the 12 volt signal, pretty simple. We've got our positive line that comes in and connects in parallel to each one of these. So it makes it a lot easier because then we only have to run one wire all the way back to hit the buck converter. The negative line comes over and connects into the relay. And then also, to simplify things, you'll see later on that I just kind of looped this ground wire to help reduce the usage of wire. And then from each one of these lights we need an individual ground wire going to the relay. And that's pretty much the basic setup of how it works. Alright, so I want to explain real quick how the Excel spreadsheet works and how you can modify it to make it work for any of the sounds that you want to do. What you'll need is obviously Microsoft Excel, and then some kind of music editor or video editor. The main thing you need to be able to do is just be able to see sounds and then be able to track when those sounds occur based on a certain time interval. So I know you can do that with most video editing software. GarageBand makes it nice and easy. So the way I've got it set up, first you'll want to put in the delay time before the song actually starts. So you can see in there it's around 500 milliseconds. So I put 500 in there, and then you put in at the top the time that you want something to change. So I want light 1 to turn on at time 500 seconds, right? So then I go back to GarageBand. I see, okay, how long is this sound on? And I just go over till when it turns off, and I see, okay, 560. I just chose to be at, as you can see, 550 up here, and then it automatically tells you how long that needs to be in there. So say I decided to be, oh no, I want it to be on until 560, it would be on for 60 milliseconds. So you just go ahead and go in, typing in here the values of whenever you want to either turn on a light or turn off a light. So then I go to the next one, it's around 650. Obviously then I type in 650 here, and that's when I want it to turn on. And then depending on whichever lights you want to turn on, you just kind of copy and paste the on buttons, and that will then fill everything out for you. So here's a better example of how that works. So see, we've got the first light coming on here, part of the code. Writes it down here to turn on light 1, and then to turn on light 2 and keep light 1 on, turn on light 3 and keep light 1 and 2 on, and so on and so forth. So really all you need to do is go in and, paste wherever you want the lights to turn on or turn off, or not to turn on, and it will modify the code respectively. And as you can see, the copy, this is what you want to copy and paste into your Arduino code. Alright, so here is the Arduino code, and I'll go over real quickly how that works in just some different variables. So as you can see, I've described each light as a variable so that it works pretty fluently with the Excel code. As you can see, I've got them referred to as light 1, 2, 3, and 4, and over here light 1, 2, and 3, 4, so that it works smoothly. And these are just the digital pins that I'm then turning on respectively for each light. So I declare those. I was going to use another lamp, so that's kind of old. And then I was also going to make it be a randomly picked. Then the setup part's just kind of declaring each of the pins that they're going to be digital outputs, because I want to output the voltage to then trigger it. And then same with these sound pins. That's what the S stands for. So this is the sound pin for the witch noise and the ghost noise. And then I want to immediately set those sound pins to high so it doesn't activate it on the Adafruit soundboard. And then I just initialize all of the lights to turn on just as it goes throughout the display. You can then do this however you want. Pretty much I like to declare separate classes as I define what I want. So for example, here is the witch. This is the code that I copied from the Excel file, and I'll just give you a quick run view of how that works. So let's just go ahead and delete that. And if we go over to the Excel file, and then I go to that part that I want to copy, just Control, Command, Shift, copy it all, and then paste it into here. And since Excel is a comment eliminated, it kind of puts it in here with quotation marks, so I found the easiest thing is just do a find quotation mark, replace with nothing, replace all, and then it gets rid of all of those for you. So it makes it nice and quick cleanup of your code, and it's good to go. It's going to do exactly as what you see here. So light 1 will turn on at 50 seconds, then these lights will turn on again at 650 seconds, and turn on at 825. Pretty much exactly how you make it look up here, that's what this code does down here. So it's pretty straightforward, pretty easy, just turning on and turning off lights based on time. Alright, I want to show you real quick how easy it is to convert sounds and upload them to the Adafruit soundboard. I use VLC, it makes it really easy. So I have my sound uploaded to VLC, it's just an MP3 file. Then I'll go over to VLC File, Convert and Stream, and then what you'll need to do is just drag and drop it. And then you'll want to select the profile. And I've already got it set up to OGG, that's what you want to convert it to. And then you'll want to select Save As File, Browse, and then the naming convention is T0, and then depending on which pin you want this sound to play. So if I want to play this sound when pin 1 is activated, I'll do T01. If I want it to play when I activate pin 2, T02. And respectively, and they've got a lot more information on their data sheet if you want to kind of get into more advanced triggering, but that's pretty much about how easy it is. And then you'll just click save and upload it to the soundboard and you're good to go. Alright, so let me give you some tips and tricks about the setup for this. Real quick, I just wanted to show you guys, this is what I used for my lights, the LED strip lights. They're actually the RGB colored, so I just soldered the 3 terminals for the red, green, and blue together to give me white, and then the positive goes to positive. So that's my ground wire and my positive wire. And then I took that and I would run it through the lid like this. So I just kind of wanted to show you how to do that real quick, some things that I learned. Here's the cap. What I would do is I'd just take a hole punch or your wire snips or something, make a good sized hole in there, and then don't strip your wire beforehand because it makes it really difficult to get through there. So what I would do is before I strip the wire, I'd feed that through the lid and then I'd strip the wire, and it made it a lot easier, especially for some of these lids where you ended up having to go with multiple wires through there. So that's one trick that I learned. It's a lot easier to strip the wire after you've gone through the lid. The next thing I wanted to show you was how I took the sound from the Adafruit soundboard to a speaker. I just took a regular headphone jack like this. Then you just clip it at the length that you want it to be at. I just clipped it down the middle, right there. And then I'll show you what it looks like. I've already got one clipped. So it has a green, a red, and a black wire. The black wire is the ground, the red is the right, and the green is the left. And you can also test that just by doing the continuity test, where left is the top one, right is the middle one, and ground is the bottom one. And then those respectively will connect to the Adafruit soundboard as shown in the wiring diagram, to the left, right, and ground terminals respectively. And then you just have a regular headphone jack that just can go into any speaker as a sound output. So these are all the lights hooked together. Not too bad. They follow down here, and here's that positive wire. Now as a reminder, this positive wire is connecting to each one of them in parallel, so that's why we only have one positive wire coming out that connects to our 12 volt DC buck converter. Then this bundle is all of the ground wires that come from each one respectively and connect into the relay. You don't have to use a 8-channel relay, that's just what I had lying around, so that's what I used. You can use however many channel relay that you want for your lights. I've got the ground loop connected to each of these, and then they connect into the normally open terminal, so that way the lights will normally be on, and then when you activate it, the lights will then flicker and whatnot. So then these are the wires that connect into the Arduino, and this is what the pins that they connect to that's shown there in the wiring diagram. And then this is the digital pins that then activate the sound coming out of the Adafruit soundboard. This is our left, right, and ground that come and then connect into our headphone jack. That's what we plug into the speaker. And then this is the power terminal right here that's powered by I had to disconnect it, but it's powered by the 5 volt buck converter. And then these two both just connect to this little electrical IEC connector, and just your typical computer jack that you're normally plugging into